Well, I'm just going to look at this problem where we've got 2 points and we want to try and find the vector equation of the line joining those 2 points. So let's get up the line that's joining those 2 points. There we go, this brown line here. And you can see I've pulled up the standard form that we get the vector equation of a line. R, which is a vector, okay, R represents this whole line, any position of any point on this line. A is how we get from the origin to the line, and B is going to be the direction vector in the line, and lambda is some multiple of that direction vector. So the first thing we need to do is to find out how we get from the origin to the line. We can pick either of these two vectors. We can pick either vectors. We can either pick the vector that goes from O to A or from O to B. And we can pick any other vector as well that goes from O to this line, but given that we were given these 2 points on the line, it's much easier if we pick one of those as our position vector. So we're going to choose A. And here we go. So the position vector OA, given by the little vector A, is going to be 3 minus 2, 5, which is just given by the coordinates. So that's going to be our A in this vector equation, 3 minus 2, 5. Next, we've then got to find our direction vector. Well, the direction vector is how we move along this line. Well, bearing in mind we've got this point and this point, then we can find the vector either AB or BA very easily by just subtracting the coordinates of one from the other. And that will give us little b here, the vector, the direction vector on our line. So there we go. We can find AB, so I'm going to go from A to B by subtracting the position of A from the position of B. So there's the position of B, minus 3, 0, 4, corresponding to the point B. And there's the position of A, 3 minus 2, 5, corresponding to the point A. And I take that away from B to find the vector from A to B, which gives me minus 6, 2, minus 1. So I've now got A and I've got B for my vector equation. And therefore we can write out R equals A plus lambda B in the form where R equals A minus 3 minus 2, 5, my vector to get me from the origin to the line, and plus lambda lots of B. Now here we've got P, which is a point on the line defined by this, and at the moment lambda is equal to minus 1, so P is all the way over here. Let's move lambda to 1, and we should realise that's just going to end up at the point B, because what we've done when we've got lambda equal to 1 is we've got this vector for OA, and then we're just adding one lot of this vector AB to it, and that gets us O to A to B, so it's at point B. And if we make lambda equal to 0, we can see we just end up at A, because we're not using any lots of B, we're just going straight to A to get our position vector of the point OP here. And we could look at many other different values for lambda depending on what we were interested in here. Alright, so this gives us our vector equation for line, and R is effectively our coordinates of x, our position vector of x via x, y and z. X-axis along here, the red axis, the y-axis along the green axis, and the z-axis along the blue axis. And we can identify any vector from the origin by just choosing a lambda value and getting our new position point on the line here.